Which means we're pulling the turbo, people.
I'm going.
We are picking up where we left off in the last episode, and that is taking care of all of the exhaust upgrades here. But I wanted to point out something. We did read the comments, and a lot of you were somewhat upset about us calling this the cheap S15 build when the portion of us painting this car was $10,000. I'm sure the modifications going on aren't necessarily cheap, but the whole premise of this build was buying this vehicle for cheap. The car itself was very cheap. If you guys have been watching our channel, then you know we don't do things on the cheap, we do things on the right. So apologies to all of you who were triggered by us calling this the cheap S15 build. It is a cheap car, not the build. So with that having been said, we are now moving on to another item that, you know, could have been a cheap, maybe a knockoff upgrade here, but you can't do that. You don't want to do that, and that is with the internal wastegate actuator. I've got an upgraded HKS one that of course came from Turn 14 distribution, and the reason for making this upgrade is I read that the factory wastegate actuator is inconsistent in terms of the way it controls boost, and it can cause boost creep. And the way to fix that is with the HKS one, which now does have an adjustable rod, and it just has better internals where these get worn out. To set our initial boost pressure, HKS does provide us with lengths. You can see here, this is for 0.8 bar, this is for 1 bar, and this is for 1.2 bar, and these are the lengths in millimeters below. We are gonna go with the 131 millimeter setup here, just because we'll have a boost controller. So we want this as a minimum boost pressure, and 0.8 bar, which I think is probably around like 12 PSI is what we wanna start off with. To give our stock T28 turbo the best fighting chance to produce the most amount of power, we are going to make some serious performance upgrades on the exhaust side, starting with what is the O2 housing, or the turbine outlet housing, as Tomei calls it. This is the factory one, and I showed you this in a previous episode. You can see how restrictive it is. You can see down here, really it bottlenecks. It pushes all the exhaust gases into this one side and then really bottlenecks down here. The Tomei unit, first of all, is a beautiful piece. This is a non-welded one-piece construction, and it flows 87% more than that thing, which is absolutely incredible. I love this because you can see they've took all the time and effort to clearance where you're gonna have possible contact issues or how it wraps around in the factory location. They've also done a lot of smart things like this here, you know, like section this out here so we have the ability to put a nut on here. You're not like constantly fighting with it, trying to get it on and then slowly moving it forward. So this is a very, very well thought out piece, and let's get to installing it. I am going to be plugging this because we are going to a standalone, which means we don't need the factory O2 sensor here. It's kind of useless to us. Here's one for you guys that were complaining about this not being a cheap build. Look, I'm cheaping out. I'm going with a used downpipe here, everybody. And the real reason is I could not find one of these Megan Racing downpipes for the SR20 in stock. They are not available anywhere. I've actually been searching for months. There has been no stock on them. And the reason why I didn't want the traditional one is because I want the flex section built into it. I do find that these vehicles having a flex helps tremendously with the exhaust. For an exhaust system, I've gone full JDM spec here with an Apexi RS Evolution. It's a big boy. It is heavy, so it's not a light system, but I think from a perspective of sound and street performance, this is going to be perfect. You can see it's got a huge resonator right there, and then it's got this massive muffler I think the piping right here is 3.5 inches DP, so it certainly levels up a little bit. Big thanks to Will over at Legend of Our Shop. He sourced this for me. It took a long time to get here. I think it was like, God, almost 6 months to get this piece, but I'm beyond excited about it. Like I love the tip on it. Kind of just has that OEM Plus look with what is, you know, a massive tip. I'm not gonna lie, that is a huge diameter for a tip, but I think it's gonna look great. So let's get this thing bolted up here and see what it looks like. I was just about to tighten down, excuse me, the down pipe onto the outlet pipe, and I noticed there was a bit of play. Can you see how much play there is? Can you guys see that? I don't know if you can or not, but you can see right there, there's a massive amount of play in the housing. And then I came over here and looked at the exhaust housing, so the turbine housing on the turbo, and sure enough, I can see that the nuts are moving when I do this rotation, which means the gasket on the turbine housing between the manifold and the turbine housing is likely dead. That is such a common failure point between there. And this further solidifies the fact that that gasket is burnt. You can see the exhaust soot right here, which is where that gasket meets. And if you watch closely right here, I'm gonna move the turbo and you can see, you see how it's moving? You see that? Right there. So there is play, which means we are pulling the turbo, people. Having done this job a few times in an S14 left-hand drive car, I can tell you, coming out of a right-hand drive car, this turbo removal was a piece of cake. Holy smokes. And the nuts holding the manifold to the turbine housing were in fact super loose, which is very puzzling because Nissan does have this, which if you look at these things, they're like these little plates that are supposed to hold the nuts in place, but maybe they weren't doing anything because it was a little bit loose. I thought the gasket was gonna be in way worse condition than it is, but you can see it's actually not that bad. Like it's not fully cracked. I did notice right along the edge here, at this point I can probably show you, it is coming apart here, see? So you can see the gasket was failing here, and I suspect this may have been, it was on the side towards the heat shield there. So that looks like it was failing there. Anyways, let me tell you something. I had the foresight to say to myself, you know what? We're probably gonna run into something. So I ordered a full gasket set for this car, which now means we can just throw this on. I'm gonna replace a couple of seals and crush washers, and then we can bolt this whole thing back together. So I've decided to forego the locking tab here, given how well it worked or how poorly it worked in this given setup here. I'm just gonna get rid of this entire setup and go to this, which is a locking nut. So it'll essentially have the same effect as this. Once you start tightening it, you can see it's ovalized here, which causes the crush, and which is gonna, I think, keep this together much better than the potential of this old setup. So that concludes our gasket job. When I was tightening the nuts to the studs for the manifold, I would have to tighten it multiple times because that brand new like multi-layer gasket kept crushing and crushing. So I would tighten it, then another bolt or nut would come loose, and it was just a weird cycle that went, you know, probably 5 or 6 times, but I think everything's tightened up. And look at this, brand new exhaust manifold from Nissan.
Manifold cover.
Manifold cover, yes, sorry. They do still make these, which is very surprising. I thought these would not be around, but they still are. And I put the dipstick in. I shouldn't have put the dipstick in. These are kind of a pain to put in, but look at that. Oh, that is gonna look minty fresh. I'm gonna grab some fresh bolts and bolt those in. I should note that I did not put this heat shield in place down there, and that is only because I don't want to get to the dyno and that rod has to be adjusted. And guess what? To take this off, you're gonna have to like raise the car up, where right now we can access this very easily. So I'll put this on after we get back from the dyno. I'm just finishing buttoning up the exhaust here, and the one thing that I've never seen before on an S chassis is this bracket here, because no one ever has stock exhaust systems. And now I totally get why so many SR powered S chassis cars have exhaust systems that flop around a ton, because they're not supported. Now bolting this in place, this bracket here to the engine mount, look at the rigidity of this whole exhaust system. So, and it was kind of nice having this flex section here, because this pipe actually had to move quite a bit to get it in line here. So it all worked out so well. You can see I have a Tomei Extreme Tie test pipe in here, and that's just because I want to see what the maximum capability of the output of this turbo is for horsepower. I do have a Jezzy Cat here, one that I ran on my old S14 that I will put back in here. But again, I want to see the true potential of a full bolt-on setup and what this car can do with this turbo. So that is going to be in place for the time being. Moving on to the fuel system here. I'm not gonna be doing anything too hardcore. I do wanna keep this simple. So I'm just changing out the injectors, which means I do have to pull the upper intake manifold. And to do that, I think it's like 5 or 6 bolts. I'm not going to disconnect any of the connectors here, because I did read online that you can simply just like pick it up and move it out of the way. We'll see if there's truth to that. I'd rather not have to disconnect everything, but I kind of feel like I will, because usually in this situation, one of the harnesses is, one of the plugs or something isn't going to be not long enough. Moment of truth here. Let's see. Okay, it's up. I don't think I guess I can access them a little bit better, but not really by much. It's actually moved it further inwards. Like, look, when I pull it off, that's when it's on. I lift it up, it kind of just like moves it forward and in. This is still relatively simple comparatively to taking everything else off, but like it's kind of funny how the internet always says, oh, it's just so easy. You can see the one of the, I think this is a coolant line here too, is also giving me a little bit of headache. It's certainly cramped in here, but I'm hoping with this little tool I'll be able to crack these Phillips screws out of here. Oh, see, this is what I was worried about. They're tight. They're tight. They've probably never been out before, and they do want to strip. Not great.
Yeah, it's strange they used a Phillips rather than like a socket head or something.
Yeah, I know. Of course they do. Oh, come on. We're close. I can feel it. I just really have to push down on it.
Come on, baby.
No, it's lifting it out. Okay, you know what? At this point, I'm gonna take the extra 15 minutes, unplug some stuff, and pull this damn manifold off. All right, we got some space now, and look at the difference. I can just grab a proper tool here, and
still a struggle.
Nope. Wow. Okay, so I lied. The one bolt. Look at all of these are now loose. I've loosened them all. So ironically,
you started on the hardest one.
I guess I chose the hardest one here. So I'm gonna give this a couple taps with the hammer, which usually can free it up a little bit. Get it in there nice and deep. Oh, there it goes. It's done. It's loose. All the caps are loose. To remove these injectors, they're kind of tight. You can't just like pull them out. You can see the O-rings are in there pretty tight. So you can put the screws back in and then leverage the side like this. And then, there it goes. And then pops out, and there it is. For injectors, I'm going with a set of Tomei USA 740cc drop-in side feed injectors. For me, are the way to go, just because you can see they pop right in. I can bolt them back in, use a stock fuel rail, and they still provide really good quality idle, and they'll meet the fueling needs that we need. I think the stock injectors are 370 cc's, so we just would have run out of injector trying to make 16 to 18 psi on that turbo. S15 fuel pump is very reminiscent for me of the GTR, where this is just like the top holder here. Doesn't actually have the pump attached to it. It's down inside there, so I'm gonna have to reach my hand in there once I unplug this here. Okay. That's it. Now, pull the whole system out of here. Whoa, look at that sock.
My God.
Holy, want to talk about a joke?
That's a monster sock right there. You have to say about a big sock, PT.
I know. I'm replacing the factory Nissan fuel pump with an AAM 340 liter per hour. So this is gonna flow way more than we ever need. It's also E85 compatible, which is nice. And what makes it even nicer is this pump is almost identical to the factory one. So much so that I don't even have to cut any wires. Look at this. Wow. Oh, plug and play there. I am gonna transfer back this huge sock that we have here. So this is gonna go on here. And of course the factory rubber boot also fits up here. So this is a huge victory from a bolt-on perspective. Looks like I spoke a little too soon about this being a bolt-on fit. You can see this pump is actually quite a bit shorter than the AM one. And when I try to fit this up, the metal tube here hits the AM pump here. So I'm gonna have to cut this back a little bit here. Changes in pitch.
Yeah.
And you're at the end there.
Old school sawing going on.
That's right. I figured that's the best way to do this without getting most amount of metal flakes into this. So I'm gonna wash this up and let's attempt this again here. Oh yeah, okay. Oh, a little too far there. Pull this back down. One last thing to note here, I am removing this pressure relief valve that was in line here with the feed line. And only because I couldn't find much info on it. What this does is it obviously relieves pressure at a certain point. And what you don't want is this to kind of, turn on or activate when you're in a full pull and the fuel demands are high, and then this relieves all the pressure. So we're going to a standalone anyways. I don't think this is a big deal. However, I am removing a substantial amount of hose out of this. We're gonna try to see if this will work before having to replace the whole line, because I don't think I've got this type of fuel hose, and we'd have to go out and buy some. There we go, I'm in. All right. I'm in, I'm on. For those of you that haven't seen this tool here, it's real handy. We got this, I think, when we were doing the Supra.
Yeah, maybe it was a Supra. Yeah, I think it was a Supra, because we were struggling with the ring on that one.
Yeah, and this just makes tightening this ring up so much easier. Look at these. I think this is only S15. I don't remember if the S14 has nice little slip-on fittings like that. I don't recall. Look at, oh, so good. And there we have it. Our fuel system is now complete. I just spoke to Forrest, our tuner that is going to be taking care of our Link ECU, and he brought up a often overlooked upgrade, and that is, you can see this is our cam angle sensor here. Our trigger wheel is right here, and the factory Nissan one is, oh there you go, crack it open, crack it loose, is almost like an infinite count one. I'll show you in a second once I remove it. And what happens is at high RPM, the signal can be lost, which is something you never want to happen on a car, because that can make things go very, very bad. So you can see here, these small little teeth there are the holes are the count. The AM one, this is a 24 tooth setup, and that means you're gonna have a much better signal and much more reliable signal. And look at this upgrade, it's super easy to do. You just drop it on like that, it goes in place, and that is it. And just like that, we are almost ready for a first start. I will just quickly go over some of the things I did. As you guys saw, there is a little bit of effort that is required to go to a standalone ECU like that Link G4X that we have. First things first, you will need an air intake temperature sensor. You can see I did plumb that into the cold side over here, and then I ran the wiring and hooked it up into the, I'll pull this out here. I tucked it away here, DP, so
you did it too well.
That's right. It's fully tucked into the mass airflow sensor. You can see right there the wiring that isn't being used for that now will be used for there, and that means we don't have to run extra wires over there. Boost controller I also plumbed in. This is a 3-port from Link. Followed their diagram, which I did have to add a boost pressure source, as you saw, into the charge pipe over here. That was done, and just some simple, vacuum lines needed to be run for the blow-off valve. I teed into the fuel pressure regulator vacuum line, and then ran a map sensor line to the ECU there, so that vacuum tube there, so that's all ready to go. And over here you saw the new battery that I put in here. This is a Mega Life battery by Buddy Club. We ran one of these on the RX-7. It is a lithium ion battery. I think it weighs in at like 7 pounds, and the cold cranking amps on it are really high. We certainly loved it in that car, and that's why I used it here. You can see the compact size is really nice. The terminals do need to be changed out, so I crimped one onto here very easily, and on the positive terminal side, I just connected this guy up, and we are ready to rock. Used a eBay or Amazon special. This was for a CRX, believe it or not. That's what they listed it as for the battery tie down, but it fit up here really nice. You didn't have to do any cutting, just used one of the existing holes in there and the side of the battery tray here, and it's on there. It's in there really nice. Just firing up the PC Link G4X software here for that Link ECU, and as you guys saw, the beauty of the Link is it is a full drop-in setup. It's pretty amazing how quickly I was able to get it into the OEM box. I did hook up that CAN Lambda wideband O2. I did have to drill that pretty big hole in the tunnel there to pass the wire through, but with that whole CAN Lambda setup, it's really nice because it's super responsive. It's very quick because it is through CAN. So we've got Forrest on the line here, and we are starting to do a bit of the calibration. The first thing is to depress the throttle, so it is fully down here, Forrest.
Okay, now we'll let off.
Yep. So,
all right, we'll calibrate it there.
That is done. Do we, I just remembered I did that 24 tooth trigger wheel. Does that need to be?
Yeah, I've got that all set up in your file here.
Oh, perfect, okay.
What we'll do before we fire, we'll go ahead and we'll turn off our injectors just for a second.
It's not a bad idea.
We'll just do a trigger scope just to make sure everything is working.
So for those people that don't know, this is essentially a scope that will map out the trigger signal as the engine is cranking over it.
Alright, it looks like we got what we need here.
Perfect. Woo! Boris, this thing is purring. Oh man. Sounds like a stock automobile here. There we go. Now we got Lambda. Oh yeah, it's running good. It's running real good. Yeah, it's okay. There it is, guys. We have ourselves a running SR. The Link is super great in the sense of, like the plug and playness of it was fantastic, and every time, you know, I watch you work and I slowly learn a little bit more and more. I do find that the software is pretty intuitive like that.
Oh yeah, I think eventually you won't even need me.
I don't know if we'll ever get there. I certainly appreciate all the help that you provide.
Oh yeah, no problem. That's what we're here for.
All right, guys, that's gonna be a wrap on this one. We've got ourselves a running SR, and we are almost finished this build, which is fantastic news. So stay tuned for the next one. And of course, if you like the video, certainly think about giving us a thumbs up and hitting that subscribe button.